So our next example again involves a cubic. This time the root is a binomial with a radical. So keeping track of the multiplying and adding might be a little bit more challenging. But we're going to start by setting up our synthetic division again. Leave myself plenty of space because I know I'll probably have binomial answers after I multiply. Again, x equals, so we're going to use the root that we're given. Drop down the 1, multiply by 2 minus root 5. Add to the negative 1, so we get 1 minus the square root of 5. Now we have to multiply this binomial by the 2 minus 5 binomial. So I'm going to show my work so that I don't lose track of anything and you guys can follow what I'm doing here. Alright, so I'm going to FOIL this out. 2 times 1 minus 2 times the square root of 5 minus 5 times the square root of 5 times 1. And then here we have a negative root 5 times a negative root 5, so that gives us a positive 5 after those radicals cancel. So combining like terms, I end up with 7 minus 3 times the square root of 5. Adding that to the negative 13, I get negative 6 minus 3 times the square root of 5, which, lovely, lovely, we get to multiply by that 2 root 5 again. So we've got the 2 minus square root of 5 times negative 6 minus 3 root 5. Showing my FOILing, we get negative 12 minus 6 times the square root of 5. Negative 5 times negative 6 is positive 6 square root of 5. And then the negative root 5 times negative 3 root 5 becomes positive 3 times 5 after the radicals cancel, or 15. So combining my like terms, the radicals cancel, and we get negative 12 plus 15 is 3, which cancels with the negative 3, and we get a remainder of 0. Remember, we're told that this is a 0. If you don't get a remainder of 0, you probably lost a negative sign somewhere, or you made a minor mistake when you were multiplying. But what it means is, go back and check your work. Speaking of which, I'm going to get rid of this so I can divide again by the conjugate. So this time, we are going to take that lovely mess and divide it by the conjugate of the root we were given. So we get to do this all over again. Yes. Bring down the 1, multiply by 2 plus the square root of 5, and the square roots cancel. So we get 3. Nice, we don't have to multiply binomials this time. We can just distribute that 3. So we get 6 plus 3 times the square root of 5, which cancel each other out. Again, you should get a remainder of 0. Radical roots always come in pairs. So if the first one factored, the second one, the conjugate, has to as well. So this leaves us with something a little bit simpler, which is nice. So setting up the factored form of our polynomial, the first root was 2 minus the square root of 5. The second root was 2 plus the square root of 5. And lastly, we got the x minus 3 after we divided by both of those. Again, we can't leave those radicals in our factored form. We've got to get rid of them. So the first thing I'm going to do is distribute that negative sign and turn these into trinomials. I'm going to leave that x minus 3, that's part of my factored form, but I'm going to multiply the first 2 together, and I'm going to set it up using my box method, because for me, that's a simpler way to keep track of all of the terms when I'm multiplying more than a binomial times a binomial. So across the top are the terms for my first trinomial, and on the side are the terms for my second. You can do that in any order because you can multiply in any order, so don't worry about you have to do the first on the top and the second on the side. Order doesn't matter. And then we multiply and put our answers inside the box, so we get x squared minus 2x, x root 5, multiplying by our negative 2, and multiplying by our negative root 5. remember what should happen is all of those terms with a radical should cancel. We want our factored form to be with just plain old regular rational integers instead of irrational roots. So we get our x squared. I'm going to do this in a different color, cross them off. The negative 2x's combine to a negative 4x. X root 5 cancels with negative x root 5, and our 2 root 5's cancel, leaving us with 4 minus 5, or negative 1. And then don't forget that binomial x minus 3. So this is the factored form of the polynomial we were given. And then the last piece is to list all real roots. So we had the root we were given. We had its conjugate. And finally, from that last term that we got when we divided, that x minus 3, set that equal to 0, and we got a 0 of 3.